In this video, I'm going to introduce coordinate geometry. Coordinate geometry is an alternative way to describe geometric figures, properties of geometric figures, as well as to solve geometry problems. In coordinate geometry, we have two perpendicular number lines. Okay, and let me go ahead and draw an example of two perpendicular number lines. And we know that on number lines we typically denote different positions by integers. So I'll go ahead and do that here. And as I said, we have two number lines, so I'm going to go ahead and do the same for the vertical number line. That'll function as a second number line for our purposes. Okay, and where they cross, that's the zero position on both number lines. That's typically referred to as the origin, and the horizontal number line is typically referred to as the x-axis. The vertical number line is typically referred to as the y-axis. And so that's going to be the basis of everything we're going to do in coordinate geometry. Now let me show you one thing it is useful for. Suppose you wanted to describe the position of a point. So let me put a red dot on the plane, and here's how you would describe that position in coordinate geometry. So can you see that it's above the 1 position on the x-axis? And can you also see that it is just as high as the 1 position on the y-axis? So therefore, in coordinate geometry, we will describe that position by those two numbers, 1 and 1, and we typically package them between parentheses with a comma in between. All right, like that. Okay, let's do a couple more examples. Let me put a dot, another red dot somewhere on the plane, and that one you can see that that is in this case it's right on the 3, the position marked with the number 3 on the x-axis, and it's just as high as the 0 position on the y-axis. So that one we're going to denote by 3, 0. Okay? And I'll keep doing more examples, and so you'll hopefully get a sense of how this works. So I'll put another one down here. Okay? That one is below the 0 position on the x-axis, and it's as high or as low as, whatever you want to call it, as the -2 position on the y-axis. So that's going to be referred to as 0, -2 in between parentheses. Okay, comment. Notice that I put the x position number first, and notice that I always put the y position number second. In other words, the y position number always goes after the comma in between the parentheses, okay? The order is important. So please remember that. X position first, y position second. All right? Also, remember that you have to put them in between parentheses, the two numbers, and have a comma in between. Okay? Let you do a little bit more tricky one now, and you can pause the video and see if you can do this one on your own. What about this purple number way up here? And what about this purple number way down here? See if you can figure out the positions of, not purple dots. See if you can figure out the position of those two purple dots. All right, and I'll do that in a second. Okay, so the answer is -1, 3 and 3, -2. Now, not only is coordinate geometry useful for denoting positions, but you can also denote geometrical figures. For example, suppose that I had the following green triangle. Okay, I can denote that triangle by giving the positions of the coordinates of the positions of the three vertices of that triangle. In this case, it's the red dots we started talking about. All right. I can also denote lines by giving 2 points on the line. All right. So, for example, the line that goes through the purple dots in the picture given by that blue line segment, denoted by that blue line segment, that can be, you can describe the line unambiguously by giving the coordinates of any 2 points on the line. Okay? Now, let me close this video by reminding you, if you haven't seen it before, how we can calculate lengths on when you have segments resting on number lines. All right? So, for example, if we had let's say, the following green line segment resting on the x-axis between -3 and -1. Okay? You can probably by inspection see that it has a length of 2 if we denote the length between two neighboring numbers by 1 length unit. Okay? Now maybe if that wasn't obvious because let's say the line segment was really long, okay, or maybe you were just given the coordinates of the ends, the numbers associated with the ends. Whatever reason, let me give you an alternative way to calculate that the length is 2. So you could have done -1 minus -3 and taken the absolute value of that. In other words, you could have taken the absolute value of the difference of the end positions. That's what I'm trying to say. So in this case, -1 plus 3, the absolute value of that would be indeed 2. Okay? Now let me do another one. Let me do one along the vertical y-axis. So I'm gonna color in a green line segment, and I want you to find the length 2 ways. Just visually counting the amount of the amount of little pieces of distance in between, unit distance pieces that have a distant length of 1. Okay, and then also doing it by this formula that I just introduced to you. All right, so do that now. Okay, so I'm going to go ahead and do that. So 3 minus -2, so absolute value of that is 5. So the length of that vertical green line segment is 5.